Good morning, students. Chapter 6 Fractions. In this lesson, we take a look at equivalent fractions. Now, let's consider this half. Okay, 1 over 2. Now, if we split up the diagram as such, we have got 4 pieces. Now, 2 are shaded, so it is the same as 2 by 4. Now, go back to half. We split up the diagram up into 6 pieces. Okay, 3 are shaded, so it is the same as 3/6. If we break it up into 10 pieces, 5 are shaded. So it equals 5/10 as well. Now we could continue on this way. We could break it up into 100 pieces, and if you would count them, you would find the 50 are shaded. So 50 hundreds, and we could continue on that way. So these all examples of equivalent fractions. Let's look at some examples. Now we are asked complete the equivalent fractions. The first one we have got is 1/3 equals something over 6. Now if we look at the denominators, the bottom numbers, we know that the first one we have got is 3, and then the other one we have got 6. We have asked ourselves, what have we done to the 3 to turn it into a 6? Well, we have multiplied by 2, so if we multiplied the bottom by 2, we multiply the top by 2 as well. 1 times 2 is equal to 2. The next one, 2/5 equal something over 20. Again, looking at our bottom numbers, our denominators, the 5, we have turned into a 20 by multiplying by 4. So, if we multiply the bottom by 4, we multiply the top by 4 as well. So, on the top, our numerator 2 times 4 becomes 8. The next one, 3 by 8 equals something over 40. Again, looking at our bottom numbers, our denominators, the 8, we have turned into a 40 by multiplying by 5. So, if we multiply the bottom by 5, we multiply the top by 5 as well. So, on the top, our numerator 3 times 5 becomes 15. The next one, 3 by 4 equals something over 40. Again, looking at our bottom numbers, our denominators, the 4, we have turned into a 40, multiplying by 10. If we multiplying the bottom by 10, we multiplying the top by 10 as well. So, on the top, our numerator 3 times 10 becomes 30. It is very simple question. How do we compare fractions? Let us say we want to compare 1 by 5 and 2 by 5. We want to find out which one is smaller. Both of them have the same denominators and hence like fractions. Since both fractions have 5 as the denominators, let us draw 2 boxes, each divided into 5 equal parts. The number of parts in each box represents the number in the denominators of each fractions. To represent 1 by 5, we color first part, and to represent 2 by 5, we color 2 parts out of the 5. Now look at the 2 figures. Which part is smaller? It is obvious that this part is smaller as lesser portion in colored. We are comparing 2 boxes of the same size, each divided into 5 equal parts. Hence, 1 by 5 is less than 2 by 5. This was easy. What did we actually do to compare them? We just compared the numerators, that's all. Since 1 is less than 2, we could say that 1/5 is less than 2 by 5. If the fractions are like, that is they have the same denominators, then we just have to compare the numerators. Consider these two unlike fractions, 2 by 3 and 3 by 5. See, we want to find out which one is greater. The best way to compare two unlike fractions is by making the denominators same. The question is, what do we choose as the common denominators? Well, we take the LCM of the two denominators as a common denominators. The denominators are 3 and 5. Hence, we need to find the LCM of 3 and 5. Since 3 and 5 have no common factors, the LCM will be their product. 3 times 5 equal to 15. We have to make the denominators of each of these fractions equal to 15. Look at the first fraction. We write 2 by 3 as something over 15. We just have to find this something to get 15 in the denominator. We multiply the denominator by 5 and keep them same. We also multiply the numerator by 5. 2 times 5 gives us 10. The ratio is hence written as 10 by 15. Similarly, the second ratio also has to be written with 15 as the denominator 3 by 5 equals something over 15. We have to multiply 5 with 3 to get 15. Hence, we also multiply 3 with 3 to get 9 by 15 as our second ratio. Now, we have the same denominator in each case. These two fractions are actually like fractions. Remember, we haven't changed the value of any of the fractions. We have just written in differently and to compare like fractions. We just compare the numerators. Since 10 is greater than 9, we can say that 10 by 15 is greater than 9 by 15. 10 by 15 is 2 by 3 and 9 by 15 is 3 by 5. Hence, the first ratio is greater than second one. Remember, the fractions are unlike, make the denominators same.